Okay, so we're going to continue with our angles in a circle. We are going to talk about inscribed angles at this time. So we just finished up with central angles. Now we're going to learn about inscribed angles. So the difference is the vertex of the angle, if it's inscribed, is actually on the circle. So if you look here, the vertex of my angle is on the circle versus earlier when it was at the center of our circle. Again, here's our angle, and then this is going to be the intercepting arc of that angle, right? So the way we're going to learn about the measure of the inscribed angle, I'm going to give you a little formula. So the angle is actually equal to 1/2 of the arc. So if we're looking for the angle, we're going to take half of the arc measure. If we're looking for the measure of the arc, we're going to multiply the angle by 2. So 2 times the angle in finding those. So if we look at example 5, it says find the measure of arc AC. So again, give yourself that visual of what you're looking for. So we're looking for the measure of arc AC. So you could ask yourself, do I know a central angle or do I know an inscribed angle? In this case, our angle is inscribed because the vertex is on the circle. So if we're looking for the arc, we want to do 2 times the measure of the angle. So the measure of arc AC is going to be equal to 2 times our angle of 35 degrees. So that arc would be 70 degrees. Okay, so 70 degrees. So you're just doubling it, basically. On example 6, it asks you to find the measure of arc BC. So we're here. And if you notice, there's no inscribed angle that meets this arc. So you're going to use what you see for the rest of your circle to help you find the measure of that arc. I see that this much of my circle, this arc is 175 degrees. I don't know this piece, arc AB, but I can find that because I know my inscribed angle is 40. So the first step is going to be to find the measure of arc. I'm going to put BA just to go in the order. Oops, sorry about that, guys. So we're going to do 2 times that inscribed angle of 40 to get 80 degrees. So I'm going to come up and I'm going to label that. I know that there's 360 degrees in this whole circle. So to find the measure of arc BC, which is what it asks us for, we're going to do 360 minus that 175 minus the 80 that we just found, and that should give us 105 degrees for this arc here. So I should be able to add all these up to get 360 degrees. Alright, so the next set of problems is just all different types of situations with inscribed angles, and we'll learn some different things about the circles and the angles. So the 2 questions you're asking yourself, is this inscribed or is this central? So it says solve for x. So in this picture, x is this angle, its vertex is on the circle. So it's an inscribed angle. So what I do is I like to draw the legs of the angle so I know where that intercepting arc is for that angle. So right here is the intercepting arc for that angle. If I knew that measure, I could half it to find the inscribed angle. I don't know that arc, it's not given, but if you look, it's also the intercepting arc of this 81 degree angle. So if I know that my angle is 81 degrees, if I want this arc, so the measure of arc AC, I'm going to do 2 times that 81 degrees to get 162 degrees for that arc. So now if I want this angle, I would simply divide this by 2. So the measure of angle, let's just put x since they called it x, is going to be 162 divided by 2, which takes us right back to 81 degrees. So what you've learned here is that if you have two angles that have the same intercepting arc, these two angles are congruent. So that's one scenario. If you come over to 8, we have a lot going on in this picture, but it's asking us to find this angle x right here. The vertex is on the circle, so I know it's inscribed. So if it's inscribed, I need the measure of this arc. So I need this arc here. Look at what else you know. You know that the central angle is 48 degrees. And what you learned from the last video is that the central angle and its intercepting arc are the same. So I know that this arc is 48 degrees because the central angle is 48 degrees. Now to find my inscribed angle, I'm going to take half of its arc. So 1/2 of 48 to give me 24 degrees. 9 is the easiest of all. It's asking us to find x, this angle. Vertex is on the circle. It's inscribed. Therefore, I want to take half of its arc. So we're going to say x equals 1/2 of 124 degrees to give us 62 degrees. Number 10, we're looking for this arc, because x is labeled on the arc. The angle across from the arc is inscribed. Its vertex is on the circle. So remember, to find the arc, we're going to do, so the measure, let me just do x again. So x is equal to 2 times its angle. So 2 times, and we know that that box means 90 degrees. So the measure of that arc is 180 degrees. 11, again, we have a lot going on, but if you look, x is a central angle because the vertex is the center of the circle. So for central, if I know this arc, I know it's the same as the arc. So you're going to use the inscribed angle that they gave you to help you find the measure of its intercepting arc. So we're going to say the measure of arc SQ is equal to 2 times the inscribed angle, so 102 degrees. Therefore, if this is 102 degrees, the central angle is 102 degrees. So it's really just memorizing the rules, guys. Next, we're going to have sorry about that, I was trying to get things situated. A couple different problems with inscribed circles and angles and triangles. So for example 12, you're going to be looking at 2 triangles, and I know this is a little hard to see, but basically this 13y minus 48, there's a degree symbol there, so it's talking about this angle. And then the 8y minus 47 degrees is talking about this. So I have 2 central angles. And if you can remember back to Math 2, these are vertical angles, and vertical angles are congruent. These 2 line segments being congruent also plays a part in that. So you're simply just going to take this 13y minus 48. We're going to set it equal to 8y minus 47, and we're going to solve that. So I would subtract 8y. So we get 5y minus 48 equals negative 47. Add my 48. So 5y equals 1. Divide by 5. So y is 1/5. Okay. Question asks us to solve for y. That's what we did, so we're finished. You could check your work by substituting 1/5 into this side, substituting 1/5 into this side to make sure those two angles are the same measure or congruent to each other. This problem is almost just like this one, except this time they gave you the arc measure. So this arc and this arc is what's given, and it says solve for B because these two segments are congruent. These two angles are congruent. Opposite arcs are congruent. So, because if you remember, central angle, arc are the same. So if these two angles are the same, these two arcs are the same. So we're going to say 8b plus 1 equals 12 plus 6b. And we're going to solve. So we would subtract 6b. I'm going to subtract 1, divide by 2, so I get b is equal to 11 halves or 5.5. Either way. And again, you could sub back in to check your work. On 14, they gave us this angle and they gave us this arc. So back to the two previous problems, if this angle is 10b plus 3 degrees, so is this angle. This is central, which is equal to its arc. So again, I'm simply going to set these guys equal to each other and I'm going to solve it. So 10b plus 3 equals 8b plus 11. We would subtract 8b. Subtract 3. So we're going to get 2b equals 8, divide by 2, and we get that b is 4. And that's what it asks us to solve for, so you're finished.